You may have noticed that the general reason for why you add fractions in a certain way is a lot similar to the general reason of why you subtract fractions in a certain way. Because of this, you may wonder if there's an easier explanation for why you subtract fractions in a certain way if you know how to add fractions. And yes, there is an easier way. In fact, there are at least two easier ways. And let's go over the first one. So I want to show that you subtract fractions by subtracting the numerators but keeping the denominators the same. If this is the case, then 6 ninths minus 4 ninths is equal to 6 minus 4 over 9. We do not know this is true yet. We're trying to show that this is true. And then I replace the simple minus sign for a plus sign and then a minus sign. Why can I do this? Well, I explained in a previous set of videos called Adding and Subtracting Positive and Negative Numbers, and a link for that set of videos is in the description of this video. We still do not know this is true yet. And then I substitute the negative 4 ninths for negative 4 ninths. Why can I do this? Well, negative divided by positive is negative, which was explained in a previous set of videos called Multiplying and Dividing Positive and Negative Numbers, and link for that set of videos is in the description of this video. But anyway, because of that, because negative divided by positive is negative, then negative 4 ninths is equal to negative 4 ninths. And yes, now we do know this is true because we're adding fractions, and we add the numerators but keep the denominators the same. And so we know the second line is true and that the first line is true. So we do know that 6 ninths minus 4 ninths is equal to 6 minus 4 over 9. For any fractions with the same denominators, except for when you have a denominator of 0, you could follow this exact same pattern. So we do know that you subtract fractions in this way of subtracting the numerators but keeping the denominators the same. Let's now do the same idea but using algebra. So I want to show that to subtract fractions, you subtract the numerators but keep the denominators the same. So I want to show that a over c minus x over c is equal to a minus x over c, where a is one number, x is another number, and c is yet another number, and c is not equal to 0. We do not know this is true yet. We're trying to show that it is true. I can change all the simple minus signs for a plus minus. Still do not know that this is true yet. And then I can change the negative x over c to negative x over c. Negative divided by positive is negative, so negative x over c is equal to negative x over c. We do know this is true because we are adding the numerators and keeping the denominators the same. But let's just make this a little bit more prettier. Let b equal negative x, and therefore a over c plus b over c is equal to a plus b over c. So we are adding the numerators and keeping the denominators the same as we're adding fractions. So yes, we do know this is true. So now we know that the second line is true and the first line is true. We do know that we subtract fractions by subtracting the numerators but keeping the denominators the same. Let's now see probably an even easier explanation of why you subtract fractions in a certain way if you know how to add fractions. We already know to add fractions you add the numerators but keep the denominators the same. Therefore we can know that 2 sevenths plus 3 sevenths is equal to 5 sevenths. The denominator stays the same throughout, and 2 plus 3 is equal to 5. Then I can subtract 3 sevenths to both sides, and then I can have the previous right side to the new left side and the previous left side to the new right side. And here we have us subtracting fractions now. 5 sevenths minus 3 sevenths is equal to 2 sevenths. And guess what? We're subtracting the numerators but keeping the denominators the same. In fact, you could do this for any fractions that have the same denominators as long as the denominator is not 0. Therefore, to subtract fractions, you subtract the numerators but keep the denominators the same. Let's now do the same idea as in the previous slide, except let's now use algebra. We already know to add two fractions, you add the numerators but keep the denominators the same. I would also like to note that in this case, A is one number, B is another number, and C is yet another number, and C is not equal to 0. So you can see the denominator is the same throughout. It is all C. But am I really adding the numerators? Well, let's simplify A minus B plus B, which would be, what would I get if I add the numerators? Plus minus can be simplified for minus, so therefore I could change the simple minus sign for a plus minus. Why can I do this? Well, I explained in a previous set of videos called Adding and Subtracting Positive and Negative Numbers, and the link for that set of videos is in the description of this video. Then I can use the commutative property of addition, or that x plus y is equal to y plus x, where x is one number and y is yet another number. I explained this in another set of videos, and the link for that set of videos is also in the description of this video. And then I simplify the plus minus as a minus. Anything minus that anything is equal to 0. I plan to explain why in the next set of videos, which should be about some common rules involving 0. And then anything plus 0 is equal to that anything. The reason for this was explained in a previous video, and the link for that video is in the description of this video. So anyway, we do know that A minus B plus B is equal to A, so I am adding the numerators. Then I can subtract both sides by B over C. Then I can have the previous right side to become the new left side, and the previous left side to become the new right side. And looky here, we're subtracting fractions, and we're subtracting the numerators and keep the denominators the same. So I do know that I can subtract fractions in this way, that this is the rule for subtracting fractions. The next video in a set of videos is about using counters to explain why you add or subtract fractions in a certain way for the case of where you have both the numerators and the denominators as positive integers. If you wish, please click on the link here below.